Hello, everyone, and welcome to our fourth unit, Factoring and Applications, Lesson 1. So today we are going to do a review of grade 10 factoring. It was a pretty big unit in grade 10, so hopefully you were pretty comfortable with it, and this review is just shaking off some rust. We will go through all of the stuff we did in grade 10 in one lesson, so this might be a good one to practice a lot of before moving on to some harder factoring later in the unit. So with factoring, we learned a few different techniques in grade 10, and the summary of the steps is written right here. So the first step you want to try is factoring by taking out or removing a common factor. Then we learned how to factor a difference of perfect squares or a difference of squares. And finally, in grade 10, we looked at factoring trinomials by inspection. And I'm going to cover all of those in this lesson. So let's get started. So the first example says factor each polynomial by removing the greatest common factor. So what we're trying to do is find the biggest thing we can divide out of every term. So if we look at the first one, A, we have 15x cubed minus 5x squared. So when it comes to coefficients, what is the biggest number I can divide out of 15 and 5? And the answer is 5, right? 15 divided by 5 is 3. 5 divided by 5 is 1. So let me restate that. What is the biggest number you can divide out of both of those and still get whole numbers? We don't want decimals, right? We know that we can divide 15 by 7, but that's going to give us a weird decimal, and it's not going to simplify anything. How many x's can we divide out? And I always like to think of the variables as how many x's can each term give equally. They have to give the same amount of terms. So the first term has 3 x's or x cubed, and the second one has 2 x's or x squared. So if they each are giving the same amount, I can take an x squared out of both of those. So you can think of it as dividing. So if I divide this by 5x squared, the first term I'm left with 3x, and the last one I'm dividing out 5x squared out of 5x squared, so it's going to become 1. So that polynomial can be factored by removing a greatest common factor. The greatest common factor was 5x squared, and then we have to rewrite the binomial with what is left. So if I pull out a 5x squared, I'm left with 3x minus 1. And you can always double check to see if this is right. And the way you do that is to just multiply that back through. So do the 5x squared multiplied by 3x and multiplied by -1. And when you do that, you should end up back with the original polynomial. In the next one, we have 3 terms, 8p to the power of 3 minus 4p squared minus 4. So what's the biggest number I can divide out of all of those? I can divide 4 out of each of those 3 terms. So that's part of my greatest common factor. Can I remove any variables? Well, there's 3 p's in the first term, 2 p's in the second term, but there's no p in the third term. So I can't remove any variables out of this. So 4 is just the greatest common factor. So what is left in my trinomial? Well, 8 divided by 4 is 2, and I still have p to the power of 3. 4 divided by 4, or sorry, -4 divided by 4 is -1, or I'll just write it as -p squared, and -4 divided by 4. In this case, I have to write the -1 because there's nothing there. Again, if you're unsure and you want to double check, if you've done that right, multiply that back through. It has to multiply by every term. And when you do that, you get 4 multiplied by 2p cubed is 8p cubed. 4 multiplied by -p squared is -4p squared. And 4 multiplied by -1 is -4. And you can see that it ends up being the same trinomial. So good to go. Factor, if possible, using the difference of squares method. The difference of squares method, hopefully you remember a little bit of this as I talk about it, is a way to factor out a binomial where both terms in the binomial are perfect squares. So if you have a binomial where both terms are perfect squares, you can factor that into two terms where each term is the product of those perfect squares. One's a positive and one's a negative, or one's an adding and one's a subtracting. Oh, shoot, I screwed that up. It's supposed to be a difference of perfect squares, so you have to have a subtraction sign in the initial binomial. So to check if this works, you want to look at both terms. So is x squared a perfect term? Yes, because x times x gets us x squared, and 81 is 9 times 9, so that's a perfect square. And it's a difference. Difference means subtraction. You can see there's a subtraction sign there. So what this means is we can split this into two terms. So I can split the x's into x times x. I can split the 81 into 9 times 9. One's an addition and one's a subtraction. And those are the two factors right there. So if you were to multiply those factors together and FOIL them, you should be able to get back to x squared minus 81. And that's just, again, the check. You can always expand these out to double check. The next one, 25a squared minus 49. The first term, is it a perfect square? Well, how do we get 25a squared? 5a multiplied by 5a. So that's a perfect square. It's a difference because there's a subtraction sign, and 49 we know is a perfect square. It's 7 times 7. So I can split this into two factors, split the 25a squared into 5a times 5a, and the 49 into 7 times 7. One's an addition, one's a subtraction. The order doesn't matter. The next one, 9x squared plus 4. 9x squared, it can be 3x times 3x, and 4 is 2 times 2. So they're both perfect squares, but wait a minute, that's a plus sign, and it's supposed to be a negative sign, so not a difference. It's a sum. So this is not possible. The last one, 16t squared minus 64. So we know 16 and 64 are both perfect squares. T squared is a perfect square. But wait a second. The first step we should always check for is, can we simplify using the greatest common factor? Can we remove the greatest common factor? And it turns out that we totally can, right? We can remove a 16, and then we're left with t squared. 64 divided by 16 is 4. Now, I can ask myself, is t squared a perfect square? Yep. Is it a difference? Yes. Is 4 a perfect square? Yes. So now I can split that into 16. T squared is t times t, and 4 squared is 2 times 2. One's an addition, one's a subtraction, and that's your final answer. All right, so now we are going to factor trinomials by inspection. So again, we are going to be splitting these into two factors. So there's a way to figure this out. And you probably did it a lot in grade 10 and thought it was weird, but it's actually not too bad. So what we're going to do is, we have a squared. That means we're going to have two factors, a times a. But we don't know what those last terms are going to be within those brackets. So a quick way to do it is, when you don't have a constant in front of that a squared, this only works if you don't have a constant in front of that a squared, is now we're looking for two numbers that multiply to 30 and add to positive 11. So I like to do this with a little multiplication table over here. So off to the side, I say, okay, what are my factors to get to 30? Well, 1 times 30 gives me 30. 2 times 15 gives me 30. 3 times 10. I don't know if 4 works. And 5 times 6. Now, of these 4 sets of factors, which one adds to positive 11? And you can see right here, positive 5, positive 6. When they multiply, they make 30, and when they add, they make 11. So that means our answer is going to be a plus 5, a plus 6. And if you're not sure, FOIL it out, and it should come back to the original trinomial. So let's do that a little bit quicker. So I have b squared minus b minus 30. So I'm looking for 2 numbers that multiply to get negative 30 and add to get negative 1. There's always a negative 1 there, remember. So looking for 2 numbers that multiply to make negative 30, add to make negative 1, so that we can write our binomials. It's going to be b and b, but we don't know the terms. So to get negative 30, it's 1 multiplied by negative 30, or negative 1 multiplied by 30. 2 multiplied by negative 15, negative 2 multiplied by 15, 3 multiplied by negative 10, negative 3 by 10, negative 5 multiplied by 6, 5 multiplied by negative 6. So when it's a negative sign, you have to be aware of it. So we're looking for 2 of these that add to make negative 1. So 5 plus negative 6 equal negative 1. So now you can say b plus 5 and b minus 6. And the order doesn't matter, right? If you put b minus 6 times b plus 5, it will give you the same answer. Here we go. The next one is x squared minus 4x plus 48. So we're looking for 2 numbers that multiply to 48 and add to positive 4. Okay, what happened? Add to positive 4. So make your multiplication chart here. 48 is 1 times 48. 2 times 24. 3 times 16, maybe? 16. 4 times 12. 5 doesn't go in. 6 times 8. I think that's as far as it goes. I can't think of any more. I feel like my brain isn't working very well right now, so if I missed one, I apologize. But it looks like none of these add to negative 4. And you got to be careful because positive 48 can be found by multiplying negative 4 by negative 12, negative 6 by negative 8, negative 3 by negative 16. But in this case, it doesn't look like anything adds to negative 4, so it's possible that this question is not possible. All right, last factoring by inspection question. So we have 3x cubed minus 21x squared plus 36x. A couple of things right now that are a bit of an issue. You can see that we have a number in front of our leading x term, and also we have an x cubed, not an x squared. This inspection only works with trinomials, where it goes x squared, x, nothing, or a squared, a, nothing, and there's no constant in front of the squared term. And we can fix all of that. Let me see if I can move this. Hang on. Quickly. Or just make it smaller. That's cool. Missed the ones. So I want to deal with that constant, and we have one too many x's in here. But the first thing we should always do is see if we can remove GCF, or greatest common factor. And it looks like I can remove 3 because I can divide all of those terms by 3, and each of them can give me an x. So when I factor that out, the first term I'm left with x squared. The second one, 21 divided by 3 is 7. X, I took one x out, so I'm left with 1x. And then 36 divided by 3 is 12. And I took that x out, so it's not there anymore. Now you can see right here I have a trinomial that fits the mold that I need to use inspection to solve it. So I have 3x, and now I'm going to split that into 2 factors, x times x, and I need 2 numbers that multiply to positive 12 and add to positive 7. So let's make our chart. 12 is going to be 1 times 12 or negative 1 times negative 12. 2 times 6 or negative 2 times negative 6. 3 times 4 or negative 3 times negative 4. And it looks like right here, negative 3 plus negative 4 gives us negative 7. So x minus 3, x minus 4. And that's our final answer. Awesome. So that's factoring by inspection. It only works if your trinomial is x squared plus bx plus c, where you don't have a constant out in front of that x squared term, and x squared is your highest or largest exponent. There's a really nice flowchart on the next, or there's a really nice like step-by-step list and a flowchart for factoring polynomial expressions. So this is a good thing to follow or have open as you're factoring. The first step is to look for a common factor. If you can remove the greatest common factor or a common factor, then that's the first step. It'll make your life a lot easier. If there's a binomial expression, which means 2 terms, if there's 2 terms, look for difference of squares, which is, if you remember, a squared minus b squared will equal a plus b multiplied by a minus b. If there's a trinomial expression in the form of x squared plus bx plus c, those are the ones we just did, look for factoring by inspection. So that would be 2 numbers that multiply to c and add to b. And then you could split that into x and x, and then just find those last numbers there. If there's a trinomial in the trinomial expression in the form of ax squared plus bx plus c, you can see there if we have a constant in front of the x squared that we can't factor out, we are going to be doing decomposition, which we will cover in a later lesson. That's one of the new things that you're going to learn. And if there's a polynomial with 4 terms, we're going to factor by grouping, which is, again, another thing that we're going to learn. And then once you're done factoring, always check to see if you can simplify even further or factor even further. There's a nice flow chart as well. So it starts here with look for a common factor. And then if binomial, look for a difference of squares. And if it's got 3 terms, then if a is 1, or if there's no constant in front of the x squared, you can use inspection. So the ones I highlighted in blue are all from grade 10. And then the new stuff we're going to learn is if we have 4 terms, we're going to try grouping. And if we get to a trinomial with 3 terms and we have an a term or an a value that's bigger than 1, or a coefficient, we are going to use decomposition. So you can see we have a pretty solid base from 10, and we're just going to expand it a little bit. I mean, they're going to get harder as well. And then, of course, as always, check to see if further factoring is possible when you are done. Okay, let's go through a couple more. I've got 2 more examples I'm going to do for you here, just because they're a little bit weird and I think we should cover them. The first one is 36 minus 9x squared. So according to that factor, that flow chart, we want to try to remove any common factor that we can. And if you look at this, you can see that I can actually pull out a 9. 36 divided by 9 is 4. 9, x squared divided by 9 is x squared. Now, I go down the list. I have a binomial, so I need to check. So this is my binomial right here. I need to check for a difference of squares. Is 4 a perfect square? Yes. Is it a difference? Yes, it's a subtraction. Is x squared a perfect square? Yes, it is. So I can now split this into two terms where I have 2 plus x, 2 minus x. And that is my final answer. 28 plus 3x minus x squared. So you can see that it is a trinomial. We have 3 terms, but normally it's given to us in descending order, where even like in your homework you can see that x squared goes first, then x, and then x to the power of 0, or just nothing. So what we can do is we can rearrange this if we want, but you have to be careful when you rearrange because the sign in front of the term has to stay with it. So for example, if I wanted to rearrange it, that negative x squared term has to be negative x squared. It has to come with it. Then we have positive 3x because that positive 3x is a term. And then here 28 is a positive number, so it becomes positive 28. So right now the issue is with this is we can't factor it just yet because we have this negative sign here. So if that's ever the case, you can factor a negative 1 out. And what that does when you factor a negative 1 out is it changes every sign. So the negative sign in the x squared becomes positive x squared. And then this positive 3x becomes negative 3x. And plus 28 becomes minus 28. Just like that. And now we can factor. We're going to factor by looking for 2 numbers that multiply to negative 28 and add to positive 3, because this is a trinomial with no constant in front of the x squared. So if I'm looking for 2 numbers that multiply to negative 28, 1 and negative 28, negative 1 and 28, 2, 14, 2, negative 14, sorry, negative 2, 14, nothing for 3, nothing for 4, I believe. Oh wait, 4 and 7, sorry. Negative 4, positive 7, positive 4, negative 7. So do any of these add to negative 3? Looks like right here, positive 4 minus 7 is negative 3. So I can say negative 1, or just negative. I can leave that as negative, and then split this into x plus 4 minus 7. There we go. That is the answer right there. You can also switch the form of this. This is like a little bit of an extension, but we can use this negative and this this factor right here with a negative sign in it. So if I rearrange the order of this, we go negative x minus 7, x plus 4. So a nice way to write this answer. This isn't wrong, but this negative sign out here is kind of weird. So what you can do is you can actually factor it in to the root or the factor that has the negative sign in it. So if we do that, it goes into both terms. So we get negative x plus 7, and then the x plus 4 stays the same. And then you can actually just rearrange the terms in this. So negative x plus 7 is the same as, just let me erase this here, 7 minus x. So it just ends up flipping the order. And you can see that this is the same as that, but it's in a nicer, it looks nicer. 7 minus x multiplied by x plus 4. Awesome. That's the review of factoring. Thanks for watching. Don't forget to like and subscribe.